All right, so this is the question that I gave you the last day. We're going to go through it quickly. Now, I'm also going to point out, when I go through this question, the last day I had my T-square and everything else set up. I'm aware some of you don't have those, so we're going to do this question entirely off second set squares, just so you can see that it is indeed possible. So, with this question, we're going to have a look at the key features of it. Now, it is pitched at 60 degrees, so this major axis is at 60 degrees. So that's an important thing to notice. Okay. There's an ellipse here. There's a circle here. And this is just a small detail. So the majority of your marks for this question, if you're in an exam, would go for the ellipse. It would actually only be about 50-50 for the two of these. Okay. Other thing they have is they've given you a focal point. That's great. And they've told you the distance that is out from the center. And have they told you? They've told you the radius here of the minor circle. So once we have those, we should be able to find our major circle, because our major radius will be from here to this point here. So that distance will be our major radius. And we'll be able to work through the rest. So, starting this question. If you just have second set squares, what you're going to do is you're going to set your set squares up like this. So, have it so they'll be able to slide like that. Bring this one up. Line it up at the top of the page. Bring it down. Now make sure you keep your your anchor set square completely straight. And scribe a line. Nice light line. Across the middle of the page like that. I'm going to zoom you out a bit there so you can see a little bit more of what's going on. Now, as I said to you before, they've said that this goes off at 60 degrees. So, what can I do? I could set my set squares up like this and go really, really complicated way around it. Or what I could do is I can use my side and set squares. I can line a horizontal set square up like this and drag it down and treat this kind of like my T-square here now, so that stays still. And they said it goes up at 60 degrees. So bring this over to roughly the middle of the page and bring my axis line 60 degrees. So that's the first main part. We have our line that's going at 60 degrees. Now, I'm going to go to check what size that was out because my printout here isn't very clear. So that's 26 millimeters to the focal point. Right. What I can do is I can also set up my set squares like this again. And between the 60 degree and the 30 degree angle, I can slide this over and just draw an axis line here. I don't know where that is yet, but it's in enough so that I might be able to just draw out the detail for this section here. All right, just make sure that the focus is working on this. Now, so what can I do? I can measure out 40 along my line and I can measure out 26. So I can measure out 40 millimeters. Remember, that's the radius of my minor circle. And from there, I can measure out another 26 millimeters. I can extend that line and go to 26. And that's where my focal point is. So label that F2. Grab your compass. And from here to here is our minor circle. So we can swing that. So this is the minor circle of our ellipse as well. Just remember that. We know that the distance from any focal point to the end of the minor axis, that's the radius of the major axis. Give it a second to focus there. And what I can also do is I can measure the distance from here to F2 and swing that back the other way to show off where F1 is. Okay. So I'm going to mark off where F1 is. Coincidence that it's that close to the line for me. F1. I said this is the radius of the major circle, so I'm going to take that distance and swing another circle around. Okay. So we have this much information. I'll zoom in just to this for a second. Now, don't know if you remember all along that I was being really, really specific about saying whether the lines that were coming out from the ellipse to draw an ellipse were horizontal or vertical, because they're not. As I said to you before, guys, if it's for the major circle, it goes, hold on now, let's go backwards in my head. So if I was drawing this, we'll split into 30, 60 to make our lives easier. So I'll line that up with line our set squares up like this. Okay. Now, once I have my set square lined up like that, I can do my angles. So divide it into 30, 60. Remember, it's 30, 60 degrees from the axes. And if you need to label the axes so that you'll be able to find them, that's okay too. So this is my major axis. This is my minor. Just so that it's easier to find. What you could also do, guys, you could turn your sheet sideways if that'll help you. Okay. So we have this. I need to find all the angles I haven't put down yet now. I'll just move you out of the way a second. I'll do my next angle. And I'll do my final angle then. So this is just breaking down the 30, 60. I'm just cheating here. Don't mind me. Okay. So we have our 30, 60s drawn in there. Now, this looks super complicated to you. So I'm going to say for your first one, you can turn the page so that it looks like normal and retake your page down. That just takes a bit of time. So I want to keep it like this for my drawing anyway. So what we said before was that if you have a line and it's coming from your major circle, so your major axis, your major circle, okay, line these up. So if it's coming from your major circle, this one up here, or this one here, it goes towards your major axis. So this one comes down, this one goes up. That's why I'm really specific about saying that, lads. It goes parallel to the minor axis, but it still goes this way. All right, make sure it's parallel with the minor axis. Bring this in. And if it's coming from the major circle, it goes towards the major axis. From the major circle towards the major axis. From the major circle towards the major axis. Okay. And the other one we've said, I'll do this one actually, is parallel to the major axis this time. If it's going from the minor circle, it goes away from the minor axis. So the small little fella runs away, the bigger fella runs towards the flight. If I can use that analogy. Okay. Bring these lines out. I remember now, lads, this is a little bit messy. And again, the reason it's messy is because I'm doing my lines a lot heavier than you should be, so that you'll be able to see them. Now, once I've that done, I can plot my points. I'm going to do this in colour again, just so you can see it. So there's 1 point, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and back to 0 again. So that's my ellipse. Now there's this fun little tool, you don't need it, but it just makes my life a little bit easier, especially when we're on the camera. So you don't need to run out the door telling your parents you need to buy this, guys. That's that bit of the curve. Oops. Okay, put this one in. And so on and so forth. So just give me 2 seconds to do this. And the last one. Alright, so there's the ellipse drawn. Not the best thing in the world. That shouldn't be as pointy as it is. But still, with the main bit of that work done. Okay, next thing is, they've said if I come 26 millimeters in, or just where this circle crosses over the center line, I'll be able to draw these small circles. Now, I don't see a radius given there so far. They've given one radius. They've given BD. Do they tell us information about BD is the question. So the line AB, they say, is tangent to the ellipse from A. So there's one of the constructions that you've done before. So if you need to go back to your books, by all means you do. So how did we find a tangent to point to the curve? So first of all, we need to find out where that point is anyway. That point is 97 millimeters back from the center axis here. So I'm going to zoom you out again. Okay. 97 millimeters back from the center of this. That's where this point is. I'll be able to go parallel to my minor axis using my side and set squares through that point. Okay, so once I have that bit of information, what I can do is I can look at this question again. And what information does that give? So we need to go back another 25 to get this line. And the width of it is 50. So if I measure out 25 on both sides of this line, I'm going to get the width of it. So here's 1, here's 2. And we need to go along the center line. So if I can extend that out, I need to go along the center line, and I need to go out another 25 millimeters there as well. So at the moment, we are drawing this section here. So, I started saying so a lot in my videos. We'll go parallel out here, nice and light because these are constructions. I'm going to go parallel out this way. And I can draw that line in solid heavy there. Okay, have that much. They've said the radius of this means out here. So what they're saying there is that if I measured the compass like this and took the radius of the full 50, the diameter along there, I could use that as a radius. And where those two meet at the top is that tail of the rocket. Now, okay, so I now have the main body, I have the tail of the rocket. They've also told me that 65 from this center point here, if I wanted to draw this circle. And they've told me it's 65 from the top point here, if I want to draw the bottom half of that circle. So we'll do that now. So we can measure 65 on our compass. Okay. Where have they said? So they've said from here, from the first point. I won't know where this stops, so I'm going to have to do it quite large. All the way around. And they've said to find where it ends, you put the needle, the apex down here, and you swing that exact same mark again, and it'll lap over there somewhere. Okay, we can tidy things up now. This comes up. We don't quite know where till. Okay. And this comes up to here. Now, that drawing looks really, really messy at the moment, but that's okay. Sorry there, guys. Right, so I'm going to leave you that much for this video because it's getting a bit long. In the second video I'm going to add up, we're going to do the tangent from the line BD. So we're going to have to find that line. I'll put in these 3 circles there.